Hi everyone, Kevin here with Leverage Integration. We wanted to take a few minutes to prepare a short video that helps explain some of the benefits of integrated CAD CAM using Fusion 360. So as you can see on my screen, this is what Fusion looks like when you first open it up. And at the top, you can see that I'm inside the design workspace. And I have a dedicated toolbar that allows me to do some designing methods. So for example, I'm going to first start off by creating a sketch. I'm going to apply that sketch to the top plane. I'm going to create a rectangle. And over here in the sketch palette, I'm going to use the center point rectangle command. I'm going to anchor it to the origin of my design and stretch out a rectangle. From there, I'm going to use the dimension tool up in the toolbar and say that this horizontal line will be 3 inches in length. I'm going to create a dimension on the vertical line, and instead of putting a dimension in there, I'm going to reference the 3-inch dimension so that it becomes a functional dimension of the other. And with that now fully defining my sketch, I'm going to go to the solids menu, activate the extrude command, and I'm going to extrude this closed profile up to be 1.75 inches tall. And now I'm going to create a new sketch on the top face of that body. I'll hit R for rectangle, center point rectangle. Again, I'm going to anchor it to the origin. And this time I'm going to create a parametric relationship using a collinear constraint from the edge of my sketch to the edge of the body. Okay. I'm also going to create a parametric relationship using a dimension command, and I'm going to dimension the distance from this horizontal line of my sketch to the edge of the body. I'm going to make that equal to 0.375. Again, you can see my sketch is black in color, which is telling me that the sketch is fully defined. Now, if I go up to the solids menu and activate the extrude command again, I can select that closed profile, and I'm going to cut it down into the existing body with a distance of -0.5. What we'll do next is I'm going to create one more sketch, and this time I'm going to create it on the bottom face of the body. Hit R for rectangle, center point rectangle, and stretch out a rectangular shape. Okay, now you can see this rectangle can float around. I'm going to select the middle or the origin point of the rectangle and the origin of my design and create a horizontal constraint relationship between them. Okay, I'm also going to create a collinear relationship between the edge of that line of my sketch to be in line with the edge of my body. And with that, we'll give this sketch some dimensional size. We'll make this equal to 0.5 inches away from the body. And we'll make the length of this equal to 1.5 inches. As you can see on my sketch, the color of the sketch is black, so I know I'm fully defined. And from there, I can hit E on my keyboard, select that profile, and drag that up as an extruded distance equal to 1/2 inch. Okay, and from there, if I want that feature to appear on the other side of the part, I'm going to use the mirror command over here in the create drop-down menu. I'm going to make sure that the object type is set to features. And down in my timeline, I'm going to grab the extrude feature, select my mirror plane, which in this case, if I hold the left mouse button over that plane, I can select the YZ plane. And you can see it's mirroring my extruded feature over to the other side of the part. So to add a few more details, I might decide to put a couple fillets on here. Again, I can select these two edges on this side of the part as well as over here. And I could make those equal to a 1/4 inch radius on the fillet. And I should have actually added a couple more fillets on the edges. So I'm going to go down to my timeline, edit feature. And I'm going to also select these corner edges out here on the outsides as well. So again, I got 8 edges selected, hit OK, and you can see we've got some nice rounded corners. I may also decide, for the sake of the design, to add a chamfer to these edges up here, which allows us to maybe break that edge a little bit, or maybe we want more of an aggressive chamfer on there, equal to 0.1. And for the most part, you can see we have a design starting to take shape. Now, maybe we have a few holes that have threads in them somewhere down on these little lands. So what I might decide to do is I'm going to create a sketch down on this face. And by using the project command, I'm going to project these fillet radiuses. Okay, and by projecting those curves, it's going to give us center points. Okay, so being in this sketch, I could move right into the hole command, and I'm going to tell it we're going to use a tapped hole. Select those sketch points, right, from those projected arcs. And I just want to make sure that down on my list I'm choosing the thread size that may be appropriate. I'm going to grab the 1/4 thread and hit OK. So for all intents and purposes, let's say we're finished our design, right? I'm going to go up to my data panel here. I'm going to hit save on this, and I'm going to call this one support block. Okay. Now, if we're ready to apply some CAM toolpaths to this model, we're going to shift from the design workspace into the manufacturing workspace. And this gives us the tools we need to, first off, define the setup and look through a series of the different toolpath strategies that we can apply to this part. So first step would be is we're going to define a new setup. Okay, and when we can see this setup dialog window here on the right side of the screen, we also see these red, green, blue arrows representing our work coordinate system. And we can move that to any one of these positions depending on where we want our program 0 to be. But in this case, I'll just bring it back to the center point here to start. And when we go to the stock definition, you can see by default, Fusion's allowing me to have relative size box selected. So that way we're actually capturing our intent. If the design changes size, we want our stock to change as well. Okay. Go ahead and hit OK. And now with our stock defined, we're in a great position to start applying some toolpaths. So I'm going to go up to the 2D menu. I'm going to select a facing strategy. And you'll see that in the toolpath dialog, we're first off going to select a tool. And for the sake of this demonstration, I'm just going to slide down to the tutorial tools inch library, which everyone has access to. And you can see here, if I grab tool 1, which is a 2-inch face mill, and hit select, and I'm going to go ahead and hit OK. Now we have a facing strategy that machines the top surface off the block down to the finished surface of the model. Next, what we'll do is we're going to use perhaps a 3D adaptive clearing strategy because it's intelligent and it can remove the material in a high-speed roughing efficient manner. And so I'm going to choose adaptive clearing. I'm going to change my tool. And again, we'll scroll down to the tutorial tools inch library. And I'm going to select maybe this 1/2-inch tool. Hit select. And when I go into the geometry tab, you can see that it's referencing the stock size. You can see that yellow boundary over the part. When we look at the heights tab, it's being very visual in how it's explaining where the bottom height of my toolpath is with the dark blue plane, as well as where the top height of my toolpath is with the light blue plane. And when I go into the passes tab, you can see that we have an optimal load step over set as 100 thou. And of course, being a roughing strategy by default, it's leaving 20 thou on the walls and the floors as well. So all I'm going to do next here is go ahead and hit OK. And you can see it's going to rough away the bulk amount of material, which in this case, I want to consider creating a toolpath that's going to finish some of these faces on the part. So again, going up into the 3D menu, I'm going to use the flat strategy. And you can see with a new toolpath, it's bringing forward the tool I used last. And again, going through some of these tabs at the top, you can see a lot of these defaults work quite well. And you can see in the passes tab, by default, we have a step over that's taking a percentage of the tool diameter, calculating at 350. So I'm going to go ahead and hit OK on the flat strategy. And as that's calculating, well, it's already done actually. I might decide to start addressing some of these holes, right? So to do this, if I right click on the setup, I'm going to create and reference a template that I've already pre-created to deal with spot drilling, pre-drilling, and tapping, say 1/4 holes. So by bringing forward a template, it brings forward that chronological process in the exact order that I had saved the template. So it has the proper tool selected. And this toolpath is actually finding the holes it needs to drive the toolpath. So for spot drilling, pre-drilling, and tapping, it was really just bringing in a template where I've pre-recorded that process and I can quickly program this part using that method. Now looking at the sides of the part, there's still some stock material around the edges. So I'm going to go up here and use the 3D contour strategy, which is really unique in how we can use it with prismatic shapes and using flat end mills to do automatic profiling around a body. So I'm just going to check a few of these parameters here. We're going to be referencing the silhouette edges for the machining boundary. We're going to allow the tool to go outside of that defined machining boundary. And when we look at some of these other passes here, we've got a maximum step down of 0.4. Again, this is being calculated probably from an expression of logic where it's taking 80% of the tool diameter. Okay, and I'm going to go ahead and hit OK. So that toolpath, the 3D contour, is going to work around the profiles of our part. One other thing I might want to consider is these sharp edges that are left on the part, right? How would we go about deburring those? So I've created a very unique template where I'm going to bring this in and show you how it works. I call it all chamfer deburring, and it's bringing in 3 toolpath strategies, in which case, does my model have model chamfers? And on this model, it doesn't. So I'm just going to remove the last toolpath that came in from that template. And I have these 2 strategies remaining here. They're red flag because we haven't selected geometry to drive them. And that's all I have to do at this point is right click, edit. And I'm just going to select the edges that I want to drive that toolpath with. Okay, so I'm grabbing those upside edges there. And down here, you can see this edge we might want to deburr it, but it also meets this vertical wall. Okay. So there's a couple features in this toolpath strategy. First off, I'm going to select the edges that I want to deburr. Come over here and we'll grab these ones on this side. And in the passes tab, I'm defining my chamfer width as a 15th thou edge break. And we have a chamfer tip offset. So this is very unique in how I have an expression of logic that's going to force the tool to cut deeper, where it's actually machining the chamfer with the top edge of the tool. And that's going to allow us to get that tool body in extremely close to that vertical wall. So I'm going to go ahead and hit OK. And you can see now we have a nice deburring strategy here. So the next step in after we create these tool paths in this CAM process is that I'm going to right click on the setup and choose simulate. We want to validate these tool paths to make sure that we're happy with everything that's happened so far. And as we go through this, right, I am noticing, a couple little red vertical flags towards the end of my simulation timeline. And I'm interested to see, what are those? What's causing those to happen, right? And so we got the 3D contour. You can see the tool paths are highlighting on the right-hand side, and there we go. So we've validated the tool path, and we've realized that we've got a potential issue here. You can see that the chamfering tool isn't sticking out of the tool holder far enough. So now that we've identified that, I'm just going to go up to my tool library manager, and I'm going to look in my current document of tools, and I'm going to find the engraving chamfer tool. I'm going to right click and edit that tool. Go to my cutter tab geometry, and we're going to say that the length below this holder, maybe it's got to be sticking out, we'll stick it out a little bit further just so we know it's going to clear. 1.75, we'll hit accept, and we'll hit close. And you're going to see that these tool paths are yellow flagged, meaning they just need to be simply regenerated. Okay, and we'll do one more quick check just to validate the entire setup. You can see in my simulation timeline, I don't see any red checks happening there. And I'm going to go ahead and hit play one last time, just to make sure that we can be completely confident when we go out to the machine. All right, so the final step in the CAM process in Fusion here is once we've validated these tool paths, we're going to take these tool paths and post-process them, right? However, what happens if you're faced with a design change, right? You're ready to take this to the machine, and now you've been asked to maybe perhaps add a bore feature to the part. So let's play that out. If I go back to the design workspace and say, for instance, we create a sketch on that face. Okay, I'm going to create a circle. I'm going to anchor it to the origin of my design. And maybe I want this circle to where it's parametrically driven from where this edge is. So what I might decide to do is create a point here. And I'm going to anchor that to the circle so that it's coincident to the circle. And I want to make that point and the origin vertical. So now I can reference this point in such a way that I'm going to create a dimension from the edge to the point. And no matter how big the part gets, this bore may move with it, where we're going to be 0.375 every time from that edge. All right, so I can hit E for extrude. I'm going to drag this shape down in here, maybe blind minus 0.625. And there is our design change, right? I could hit save on this document. I could add a version description and call this one Rev2 with bore. Right, so Fusion's going to automatically do automatic versioning control every time you hit save. So when we go back to the manufacturing workspace, notice that our toolpaths are red flagged, or they've got a yellow warning on them. All we're going to do is right click and generate. Okay, so that is really how seamlessly design changes can happen. Even though you've done a bunch of work ahead of time with programming some toolpaths, we've now implemented this design change and we're now ready to post-process. So going up to our actions here, we're going to select post-process. And I'm going to select perhaps whatever post-processor that aligns with the machine that I have. I'll grab this Haas Next Generation Control Post, and I'm going to go ahead and hit post. So what's happening is that post-processor is extracting all the information from those toolpaths and ultimately giving us this G-code, or what we call a CNC program, that we would send to our CNC controller. Now, the beautiful part of this is that with working and using integrated CAD CAM, you could see the benefits of being able to quickly create a design change and have your toolpaths update. However, you may notice with programming parts every day, every week, every month, that you're finding out that you're kind of repeating the same steps over and over again. So what if we could select these toolpath strategies, right click on them and store them as a template? Okay, and I'm going to call this one machine most parts. Okay, so I'm capturing this machining process. I hit save, and if I go to my data panel, and I'm going to expand open and open up a totally different part. It's called base flange. I just had it saved in my project folder here, just so I could open it quickly. And say, for instance, here's a totally different part, right? I'm going to go to setup, create a new setup. I'll define, my stock boundaries. Maybe this time we have, 0.175 inches around the outside of the part. Maybe we have a little bit more material here on the bottom that we're hanging on to. Or, you know what? Maybe we have, Talon grip vice jaws. We're going to hang on to 0.1 in the vice at the bottom. Going to go ahead and hit OK. And instead of creating CAM toolpath strategies from scratch, this is the benefit of integrated CAM and automating your workflow using Fusion. I'm going to right click on the setup, create from a template, and we call the template machine most parts. So it's going to bring in that strategic list of operations, and you can see they're already starting to execute themselves on this model. We have a facing toolpath. We have an adaptive roughing toolpath that removes the bulk amount of material, right? We have the flat strategy that's going to get in there and machine off those flat faces. And of course, these spot, pre-drill, and tapping, these particular toolpaths are set up in a way that they're searching for holes that match, a 201 thou pre-drill hole feature on the part. So it's automatically spot, drilled, and tap those holes for us. We also have the 3D contour is finding those profiles. Now you'll notice that the chamfering operations, they did not update because they're 2D operations and they require us to select geometry to drive them. So I may decide to go to this one here, edit the operation, select the profile up here, maybe on the outside out here, okay? And of course, maybe we got a few vertical wall conditions. I can reapply that toolpath down here, right? And if I go ahead and right click on this setup and hit simulate, and we can kind of get a comparison of, where is the remaining material still need to be machined away, right? Where I see blue, I still have more toolpaths to create, right? We've got these counterbore holes, and it looks like there's a drilled hole that has to get drilled in there as well. We got a few other holes up on top, and you can see I may need to use a smaller end mill to get in here and machine out these smaller corners. The point being here is that I now have, when I go to my info tab, actually go to statistics tab, I have 22 minutes of machining time where I can feel pretty confident in post-processing this sending it out to my machine, and I've just bought myself 22 minutes to either finish programming this part, right? And also maybe during that time, I have time to quote the next job, right? And so this is some of the benefits you can see in using integrated CAD CAM using Fusion 360. And I really welcome you to reach out to us through our website, which is www.leverage.ca, and we would be glad to work with you on your next project. Thanks so much for watching, and we look forward to hearing from you soon.